So review number 2 is about polynomials, which is simply the sum or difference of many monomials. In the first review that we did, we talked about monomials. The highest exponent of a polynomial is called a degree. Now that only works if there is one variable in the polynomial, meaning that there's no other variable other than x, or maybe your entire problem has the variable y. But if you have a problem that has an x and a y in it, the highest exponent is not the degree of the polynomial. So the highest exponent of a polynomial called a degree, as long as your polynomial only has one variable throughout the problem. In standard form, that means to write the exponents in descending order. Descending order means the largest exponent all the way down to the constant term if you have a constant term. So classifying polynomials, I have listed some of the classifications by degrees and the number of terms. So if you only have a constant in your problem, that's just a number, the degree is 0 because you do not have a variable in the problem. A degree of 1 is considered linear, which means you have x to the first power, and that's the largest exponent you have throughout your problem. Quadratic means your degree is 2. The cubic means it's a 3. Quartic means the largest exponent in your problem is a 4. And quintic, the largest exponent in your problem is a 5. Now, that does not mean that you can't have additional exponents. It just means that the largest exponent in your problem would be a 5. Now, classifying polynomials as specific polynomials based on their terms. So a monomial is one term. That could be 2x. A binomial could be x squared plus 2x. Notice that both of those terms, separated by that addition sign, based on the definition of a polynomial, a sum or difference of monomials, they both involve x and only x. Now, one of them is an x squared, the other is x, and that's fine. Trinomial, you could have x squared plus 2x plus 4. That is a trinomial. That is 3 terms. Now, you could subtract, by definition, sum or difference. They don't always have to be added together. Now, an example of a polynomial could be x to the third minus 3x squared plus 2x minus 4. That's 4 terms, and they are all separate, 4 monomials separated by either a sum or a difference, an adding or a subtracting scenario. So now we're going to review some of the things that you should recall. And if you don't recall them or need additional help, please make sure that you ask. But you should recall these from your Algebra 1 or Algebra 2 classes. And some of you may have even been exposed to this in middle school, and I know for some of us that's a long time ago. Now, the directions for adding and subtracting say simplify, so we're going to combine like terms, and we're going to write our answer in standard form. Then we're going to classify them. So in this particular problem, we're going to, when you add or subtract polynomials, you are going to combine like terms. And if you recall what combine like terms mean, like terms have the same exact variable and the same exact exponent, which allows you to add or subtract those terms' coefficients. So I have a b squared and an 8b squared. Since I am asked to add, I'm going to add 1 plus 8, and that gives me 9b squared. I have a b and a negative 2b, a 5b and a negative 2b. So 5 plus negative 2 is positive 3. Bring along the b. And then I have 2 constant terms, negative 11 and negative 7. So I should be thinking negative 11 plus 7, negative 7, is negative 18, not 19, negative 18. That would be the polynomial. Now, that would be the simplified version of the polynomial. You are asked to write it in standard form. If you look, all of my exponents are decreasing. My first term has the biggest exponent, b squared. Then I drop to a b to the first. Then I have my constant term at the very end. As far as identifying, I have 3 terms, which makes it a quadratic. And since I have 3 terms, it is also considered a trinomial. The reason it is a quadratic is because of the b squared. Here, I'm going to subtract terms, so I have to change my mindset a little bit. I have to go through, I have a w squared here, and I have a w squared here. Notice that in the second group, the w squared is not the first term. So I have to match up the like terms, and those are the w squares. Now we are subtracting this time, so I need to think about subtracting the coefficients. 3 minus 3 is 0. So those two w squares basically cancel out because you don't write down 0 w squared. You only write down anything that is a number, has a coefficient other than 0. So the second thing I do is I have a 2w here and a 7w here. I need to subtract those. So I should be thinking 2 minus 7, that gives me negative 5w. Then I have my constants. I have a negative 6 and a 9, but I need to subtract those. So I should be thinking negative 6 minus 9, that gives me negative 15. Now, that would be my answer. The simplified version, we have to identify it based on the degree. The degree is a 1 because that is w to the first power, and that's the largest exponent. So based on the degree, this is considered a linear polynomial, and I have 2 terms, which makes it a binomial. The 2 terms in this problem, in this answer, are negative 5w and negative 15. So once again, it is linear because the biggest exponent, the biggest power, is a 1. It is a binomial because there are 2 terms in that answer, negative 5w and negative 15. Example number 11, we are subtracting again, so we have to go through and match up the like terms. Now, I'm going to do this a little bit different because as I look through this problem, I know my answer has to have the biggest exponent first. So I'm going to go after the biggest exponent, which is y to the third. I have a y to the third in the first group, and I also have a y to the third in the second group. So what I should be thinking mentally is 1 minus negative 3. That is 4y to the third. The next thing I'm going to do is look at my y squared because that is 1 degree less than where I started. So I have negative 3y squared in the first parentheses and 4y squared in the second. I should be thinking negative 3 minus 4, which gives me negative 7y squared. Now, in the first parentheses, I have a constant term, but I do not have a constant in the second parentheses, but I do have an extra term in the second parentheses, which is a y. Now, when you're trying to put your answer in descending order, the y would come before the constant because the constant is always at the end. But notice this particular y follows the subtraction. So you are subtracting that y. R2 already has a negative in front of it, so it stays negative 2. I do not have any other term to combine negative 2 with or the y with out of the second group. So therefore, that is my answer. Now, as far as the degree, the biggest exponent is a 3. So this is considered cubic because the exponent, the largest exponent, is a 3. And since I have 4 terms, it's considered just a regular polynomial. There is no special name like monomial, binomial, trinomial for groups of 4 terms. So here in example 12, we're going to add like terms. So once again, I'm going to start with my biggest power. I have a k to the third in the first one, but notice I have no k to the thirds in the second group. So I'm just going to leave 5k to the third alone. I do not have any other terms that I can combine with that. Now, I have a negative k square and a positive k square. I have a k square in both groups. So I'm going to add that together. I should be thinking negative 1 plus 1, which is 0, which means the k squares drop out because we don't list 0 k square. Now, I have 2 constant terms, the 7 and the 2, but I also have a k to the first power that I do not have anything in the first group to match with. So I'm going to write down that negative 4k first. Then I'm going to add my constants. 7 plus 2 is 9. And that gives me my simplified answer. Now, as far as classifying this polynomial, I have a degree of 3, so it is another cubic function. But I only have 3 terms this time, and that is a trinomial. All right, so that is a quick review of adding and subtracting. Now we're going to do just a little bit of multiplying with our polynomials. We're not going to do all of these examples. We're just going to do a couple of them. So example 13 is multiplying. So you have heard of distributing. So what I'm going to do is I'm going to take the binomial x minus 3, and I'm going to distribute both of those terms across the second group, which is a trinomial. So what I'm going to do is I'm going to take x and I'm going to multiply it all the way through. That one term gets multiplied by all 3 terms of the trinomial in the second group. So x times 2x squared is 2x to the third. X times 6x is positive 6x squared. Let me go back and write that a little bit clearer. Our first term was 2x to the third. Our second term is 6x squared. Our last term is x times negative 7, which is negative 7x. Now I'm going to do the same thing with the negative 3. So negative 3 times 2 gives me negative 6x squared. Negative 6 or negative 3 times 6 is negative 18x. And negative 3 times negative 7 is positive 21. Now, once you get to this point, you need to go through and combine like terms. So I have no other x cubed terms, so I have nothing to combine with that 2. I have x squared or 6x squared and negative 6x squared, which means those terms drop out because that becomes a 0. I have negative 7, negative 18, so I'm going to add those together. That gives me negative 25x. And then I have the constant 21 at the end. Now, this also says make sure you write your answer in standard form, and it is because our exponents are descending. They are counting down, and the last term is the constant. It also says to classify. So this is cubic because the degree is a 3. The biggest exponent is a 3. And it is a trinomial because we have 3 terms. In example 14, we have a couple of things going on. If you recall, to multiply a binomial times a binomial, you FOIL. And in the second group, we're going to distribute two terms that you should be familiar with, foiling and distributing. So I'm going to FOIL the first one. Very similar to what I did in example 13, I'm going to take the 4t and distribute it or multiply it times the two terms in the second group. So that would give me 20t squared. 4t times 5t is 20t squared. 4t times 3 is positive 12t. Once I do that, I'm going to take my negative 1 and do the same thing, multiply it times the 5t and the 3. So that gives me negative 5t and negative 3. So I have done all the foiling that I need for the first two parentheses, first two groups. The second group, I'm going to take negative 2t and distribute it across the parentheses. So negative 2 times 10 is negative 20t squared. Negative 2 times negative 9 is positive 18t. Once you clear all the parentheses, you will need to go through and add up like terms. So 20t and negative, or 20t squared and negative 20t squared, they cancel because they add up to 0. I have 12 and negative 5, which is 7, and 7 plus 18t gives me 25t. So I had 3 terms to add together, not just 2. And then we have negative 3, which is a constant. There are no other constants in the problem, so we write that down. As far as classifying, this is linear because the exponent is a 1, t to the first power, and it is a binomial because there are only 2 terms in the final answer. The last example I'm going to do is I'm going to do another FOIL example. So when you have that outer exponent here, that tells you to write down 4j minus 7k twice, and then you will FOIL that like we did in example 14, the first part. So I'm going to take the 4j and distribute it here. So that would be 16j squared minus 28jk. I'm going to do the same thing with the negative 7k distributed across. That's negative 28jk plus 49k squared. I'm going to have to go into this space because I write a little bit big sometimes. Now I'm going to go through and I'm going to add up like terms. Well, the only 2 terms that I can add are these 2. They are the only 2 that are like. So my final answer, simplified answer, would be 16j squared minus 56jk. If you write kj, that's fine. But normally the variables need to be in alphabetical order, and j comes before k in the alphabet. And then our final term would be the 49k squared because I do not have any other terms to add with it. Now, in this one, we were talking about the fact that I have multiple variables. So this one is a little bit hard to classify as far as a degree is concerned. So we're not going to classify it as a degree, but it is a trinomial, or based on degree, but it is a trinomial because it does have 1, 2, 3 terms in it. I hope this helps. I hope it gets you started with some of your review for polynomials. If you have any questions, please make sure that you ask.